Hello and welcome to video lesson 2.2, rational functions. So there are a few things to go through. We'll go through them one at a time, and hopefully by the end of this will be a nice summary of what we've done in class. Three different types of asymptotes. We have vertical, horizontal, and oblique asymptotes. Vertical asymptotes are based off of the denominators, NPVs. Okay, this is very key. Oh, let's do a different color than that. The NPV from the denominator. The horizontal asymptote is based off of a vertical translation. So if you're the only way that you would have it, so normally it's y equals 0, right? But if you don't have 0, it's because there's been a vertical translation. And then the oblique asymptote is diagonal. It's weird. Don't need to know them in depth, but you need to know how and why they happen, and I'll take a look and show you guys in a moment. Okay, so with that little overview, let's try an equation here, see if we can, or a function here, and see if we can graph it. So let's first of all, we're going to have to take the denominator and actually simplify it. So factor it in this case, so minus 3 and x plus 3, and then plus 1. So that little plus 1 there tells us the, well, first of all, yeah, we have the plus 1, which tells us y equals plus 1 is our horizontal asymptote. So I'm just going to put a dotted line there. Y equals plus 1. Okay. We also have an asymptote at x equals, because it cannot equal, right? Cannot equal -3 and cannot equal +3. Okay, so let's just draw those asymptotes as well. And +3. Okay, so now that we have these asymptotes, we're doing quite well. Okay, but you know, the classic question here is, are we curving like this, or are we curving the other way, right? Are we curving like this? And how are you supposed to know? Well, let's actually test this out and see if we can figure it out. So first of all, what we can do is see if there is a value of x that is 0. Okay, if we can figure out the 0 value, that'll tell us if it's in this quadrant or if it's in this quadrant. Okay, so if x is 0, then what happens? So we have 1 over -3 times +3 plus 1, which is like 1 minus 1/9. So it is definitely positive, and it's going to be, it's going to be down here, 1 minus 1/9. So it's actually going to be very close to this asymptote, but not quite touching that asymptote. Okay, which means that we're probably going to be curving this way here. Well, we will be curving this way. Okay, and it'll look something like this. And let's just do a couple little quick checks here to see if we can actually, figure this out here. So what if y equals 0? Are there any values of x that can make y equal 0? Yeah, so if y equals 0, then what we're doing is we're solving this equation. Okay, so that's not too hard. So let's move this over. So we're going to have 1 equals, and then a negative, so it just flips. To have negative squared and plus 9. Okay, so it's flipped kind of strangely, but still works. Then if we take the the x value, or this 1, and move it over, it's minus 1. Actually, let's move the 9 over, which is minus 9, so then we have negative 8, negative x squared. So the negatives cancel, so we have x squared equals 8. So 8 equals the square root, the positive or negative square root of 8. Okay, which could also be written as positive or negative 2 root 2, using some of our radical rules that maybe you've forgotten from last year. But this kind of helps us know that it's actually going to be quite a big number, bigger than 1. So the numbers where y equals 0 are going to be, oh yeah, they're going to be slightly wider. It's going to look more like this. Okay, so you can just kind of test a couple numbers out to make sure your direction is right, but it's going to look something like that. Okay, again, doesn't need to be perfect. Just make sure your directions are right and these different asymptotes are correct. Okay, let's take a look at this next part, where we have a polynomial on top and the bottom. So we have the n polynomial, which is the numerator, the d polynomial, which is the denominator, and they're polynomials, and there are different situations or scenarios based off the degrees of the polynomial and the denominator. So if the degree of the polynomial on the numerator is bigger than on the denominator, we have an oblique asymptote. Okay, if the degree is greater on the denominator, then we have the normal one, which is what we just did, the horizontal asymptote at 0. I'm calling this the normal one because this is the most common one that we look at in this course. And then the degree of the numerator and the denominator are equal, then you can find the horizontal asymptote at the leading coefficient of the top divided by the leading coefficient of the bottom. Okay, so kind of a weird situation, but yeah, let's do some example questions here. So first of all, we have this question, which we can, again, we can factor the top. Okay, but even if we factor the top, you're going to notice that our degree is actually higher at the top. So I can't. Well, we're going to just graph it with our calculator. But what you need to be able to show is that, or recognize, is when that degree is higher, this is going to be oblique. Okay, so let's just plug it in our calculator so you can see what that looks like. So x squared minus 1 over x plus 2. And let's just do standard. So it looks really weird, okay, but basically there's a oblique asymptote that kind of looks diagonally like that, and it curves kind of like this and like this. Kind of a weird case, but like I said, you don't need to be able to draw it, you just have to be able to recognize it. Okay, this case, we actually have a higher degree on the bottom than on the top, so let's go ahead and factor that out, because we always need to factor first. So we have positive 3 and negative 2, and we have x minus 4 on top. So since we have, this equation here, we have the we don't have any k value, so that means we're going to have a horizontal asymptote at 0. Okay, and if you look at your denominator, x cannot equal negative 3 or positive 2. So that's negative 3, positive 2. Okay, so again, don't know what direction it's going to go. So I just like to plug in 0, x equals 0, and see what happens. So I find that the easiest way of just trying things out is using a 0 value. 0 squared plus 0 minus 6. So this is negative 4 over negative 6, which is positive 2/3. So that would be that point, which is probably not the lowest it gets, because probably looks something like this, because it's not in the center of that part there. So it's going to look something like this. Again, does not need to be perfect. It's just showing roughly what it's going to look like. So let's show it on the graph here, on the graphing calculator, so you guys can actually see it and make sure that it looks correct. If you do have a chance and you're on a written response, always check it with your graphing calculator just to make sure. But as you can see, that is about right. Okay, again, the big thing is you're looking for that those asymptotes though. Okay, this one is the weird one. So first we had higher degree on the top, then we had a higher degree on the bottom. The weird one is when they have the same degree, top and bottom. Okay, so there's some weird algebra that needs to happen. It's pretty cool, but let me show you guys. So otherwise, you're not going to be able to, you can just kind of memorize how this works. It'll be, 6 over 3 because it's the highest or leading coefficient on top over the leading coefficient on the bottom. So you can do that, and it's lame, but we can check that at the end. But we should have a horizontal asymptote of 2. Okay, and the bottom should have a vertical asymptote at negative 1/3. Okay, so again, not perfect. Let's go ahead and let's try to see if we can rearrange this. So what we're going to do here is we're going to try to make both the top and the bottom look like the same function, or look like the same thing so that something can cancel. So what we're going to do is write the top as if it's the bottom. Okay, so 3x plus 1. How can we do that? Well, the only way we can do that is if we take the 2 out, which would mean that if it went in, that'd be a positive 2, and then subtract by 3. So you're asking yourself, what the heck is going on here? Well, it's rearranging this first thing into the second thing. Okay, so if we FOILed that thing back out, if we simplified it, right, you'd notice that it equals the first one. So let's just go ahead and show that right now, so that you can actually believe me here, because it's pretty weird. It's really weird. I'll give you that. So it's 6x plus 2 minus 3, so 6x minus 1. You can see how those are the same two equations. Okay, so pretty whack like wacky here, but hopefully you can see how that actually works. So now that we have that, we can actually split it up into two different fractions, both of them over x plus 1. So one being this first part, okay, and the second being a negative 3 x plus 1 like that. So this first one here, hopefully you can see these two parts can cancel. So it's y equals 2 minus 3 over 3x plus 1. Okay, which if you just kind of think about it backwards, this could be on the other side. And so it's kind of weird. I get it, it's kind of weird. But we basically have a plus k. So let's just rearrange this one more time. So you can see it's a plus 2, right? So we have a plus 2, which, again, beautifully is exactly the leading coefficient at the top, the numerator, divided by the leading coefficient at the bottom, the denominator. Okay, so we have those two, proving where the horizontal asymptote is. We know where the vertical asymptote is by just looking at the denominator here. X cannot equal negative 1/3. Kind of a weird one, but that's fine. So the question is, where does y equal 0? So let's just find an example of this so that we can work with it. Let's go y equals 0. What's going to be easier? Probably we have to use this one. Okay, let's move the 2 over. So now we're going to have negative 2, negative 3 over 3x plus 1. Then we're going to move that over. So we're going to have negative 6x minus 2 equals 3. And then we're going to, let's just move it all so it's all positive. So 6x plus 2 equals 3. Then let's move the 3 over, so we have 6x minus 1 equals 0. Which I guess is right off the beginning, obviously. Okay. Well, that's fine. So x equals, right, because it's the numerator. That makes a lot of sense. X equals 1 over 6. So, again, kind of a weird one, but it's going to be here somewhere is our 0 point. Okay, which means that it's going to curve closer and closer to 0 here, and it's going to look something like this. Again, doesn't need to be perfect. It's just trying to show roughly how this is going to look. So we can try this out just to show what that's going to look like. So we've got 6x minus 1, 3x plus 1, and it'll graph and it'll look very similar. Okay, so those are all the weird asymptote situations. You can also have discontinuity points or holes. These can occur when the NPV that is found on the numerator is also found on the denominator and therefore cancels out. So every time you factor, you just have to be aware of that. So let's go ahead and try to factor this one and see if we can figure this out. So you're going to factor, you're going to list the NPVs, and then see if anything cancels out. If it cancels out, it's a hole. Okay? So x, so we're going to have a plus, we're going to have a minus. No, we're going to have two minuses. We're going to have minus 3 and minus 1. Yep. And so what will happen is we know that there are NPVs. X cannot equal 1 or 3. Okay? But if we keep simplifying here, it's 1 over x minus 1, which means that this is actually the asymptote. So this is an asymptote, whereas this one canceled out, and this is a whole. So let's just make sure we do that right. So asymptote at 1. Okay, and a whole at 3. So we're going to have to watch for that one in a moment here. Let's go ahead and just see, based off of the original equation, y equals 0 if x equals 3. So it'll be here, okay, but that's a whole. So let's use, so that's a whole there, which is also fine because it's also going to have a, oh no, that won't work, yeah, because it's going to have the horizontal asymptote. Okay, well, let's try x equals 0. Let's see what happens if we do that. So negative 3 over negative 3 times by negative 1. So that would be 2 negatives, 3 negatives, so it's negative 1. Ah, perfect. So it's going to look something like this. There you go. It'll look something like that, where x cannot equal 3, so there's actually going to be a whole at this 3 value there. So just put that hole in when you're drawing it. So actually, we should draw it a little bit better than that. To draw a hole, you kind of just draw it like this, with a circle around that spot. Okay, now holes are hard to see if you're doing it in your calculator. You actually have to be looking for them. So let me show you what I mean by that. Your calculator won't really show you the hole. X minus 3, x squared minus 4x plus 3. Okay, so if you graph it, it kind of just looks like the graph. That's the problem, okay? It looks right, but there is a hole that you can't see unless you go into the table, and you can see that there is, that's the asymptote at x can't equal 1, but there's also the hole at x cannot equal 3. So be very careful about that. When things cancel out or simplify, that's a hole. All right. I hope this video helped you better understand rational expressions, and yeah, leave a note in the comments if you guys need any help with anything. Good luck!